Welcome to DP Tutorials by Donny Jarwa. In this brief teaching module, we will discuss on a topic which is continuous charge distribution. And when we talk about charge distribution in physics, we learn about these charges which are residing on a body. So when charges resides on a body, that means it might be that the charges are residing on a straight line, it might be that the charges are residing on the surface, or it might be that the charges are residing on the volume. So all charges which resides on a body should always be closely spaced. Okay? It should always be closely spaced. So I have written over here that means the charges should always be closely spaced. And this charge distribution, when the body is, when all the charges are distributed over a straight line, that means this charge distribution is defined as a linear charge distribution or linear charge density. Now, linear charge density is defined as the total number of charge per unit volume. Say, like for instance, if Q is the total number of charge in this given body, and if L is the length of that given body, then the total number of charges on that given body divided by the length of that body, that will give us our linear charge density, which is lambda. Say, like for instance over here, if I assume that the consider a certain portion of the wire and let that certain portion of the wire be having an elementary length dl. This dl is defined as your elementary length, and it will enclose certain charges inside. Let dq be that small charge. So over here, for that small element, which means that if dq be the charge in that small element, then lambda will be the corresponding linear charge density. So in order to find the total charge, what do you have to do? You have to take integration. So in this case, we will cross multiply dl this side. And the moment we take the integrating both sides, or like in this step only, if I integrate both sides, then what do I get? Integration of dq is nothing but q. Integration of dq will give us q. And over here, this will be the line integral of lambda dot dl. This will give us our equation for finding what? For finding the total charge within the given body, provided if we know lambda. And in physics, we need to also learn about the SI unit of lambda. So the SI unit of lambda, or linear charge density, is coulomb per meter, or we can write as coulomb meter inverse. Okay? Coulomb meter inverse. Then another important term, which is our surface charge density. So the surface charge density is defined as the total number of charge residing on a given surface divided by the area, or we can say that surface charge density is the total charge per unit area. Like for instance over here, let us consider these charges, these closely spaced charges residing on this surface, which is in the form of a rectangle. Now, if we want to find the surface charge density over here, it is given by that formula, Q divided by A. What is our A? A is our area. Okay? Our A over here is nothing but the area of that surface. So A is the area of that given surface. A is the area of our given surface. Surface, it might be square, it might be in the form of a rectangle, or the surface might be in the form of a square where I can enclose the charges inside. And from here, the area, depending upon different geometrical shapes. That means if it is the circle, that means it will be pi r square. If it is if the area in this case is in the form of a length of a rectangle, that means you have to know the corresponding length, you have to know the corresponding breadth. So these are the features how to find out. Then surface charge density is denoted by this letter sigma. What is this letter called? This letter is called sigma. Okay, by the Greek letter sigma, and this sigma is equal to Q divided by A. Q divided by A. So likewise, you have to also find the SI unit of this surface charge density. So the SI unit of surface charge density is Coulomb meter square inverse. Coulomb meter square inverse. Why meter square inverse? Because the SI unit of area is meter square. Then, in the same sense only, suppose let us consider a small area or a small surface within this given surface. So if the area of if dA is that small area and it encloses charge small charge dq within this surface, that means in order to find the total charge, that means this will be equal to dq upon dA, and that small elementary charge for a small elementary area, the surface charge density is denoted by sigma. And from here again, in order to find the total charge, we have to again integrate the equation. In order to find the total charge, we will again have to integrate the equation. Like in this case, we will first multiply dA to the left hand side of the above equation. Then we will have sigma into dA. And in this case, once we integrate this equation, integration of Q is Q, and over here we have integration of sigma dA. But keep in mind that this integration is a special type of integration which is known as the surface integral. In physics, we will denote this dA, integral, by S. Integral of S. So in this case, this integration will be denoted by S. Why we write as S? Because it is the surface integral. That means if I can divide this volume into small elements, or elementary areas. Similarly, for linear charge density, that means this is what is defined as your line integral. So next part will be what? Will be our volume charge distribution. In volume charge distribution, that means we have the charges are residing in the volume, in the body, which is considered as the volume. Say like for instance, the charges are residing on the volume of a particular body, then the volume charge density is defined as charge. Charges per unit volume is defined as what? Charges per unit volume is defined as what? Volume charge density. It is denoted by this formula, rho equal Q divided by V. Rho equal Q divided by V. Similarly, over here also, you have to find out what is the SI unit. So the SI unit in this case will be kilometer cube. Why kilometer cube? Because volume, the SI unit of volume will be what? Will be meter cube. So in this case, if I want to find the total number of charge for a small volume, then in this case, I will take this small volume over here. Okay, I will take this small volume over there, and then when I take that small volume over there, we will try to find out, okay, what is the total number of charge on that given volume. This is a cube, so we'll take the volume also in the form of a cube. Okay? So when we take this volume in the form of a cube, that means that let dq, okay, let dq be the small elementary charges which are inside this small volume, having whose volume will be in the form of dv. So in this case, the volume charge distribution. Remind that this is volume charge distribution. This letter is the Greek letter rho. This volume charge distribution. This will be equal to 1. This will be equal to dv, dq. I mean divided by dv. So if you want to find the total charge, if you want to find the total charge, if you want to find the total charge, that means it is dq. When I say total charge, that means total charge of all this entire volume. So we will cross multiply dv this side. You will have this is your rho, this is your dv. Taking integration on both sides, that means this will be your volume integration. Integration of dq will be q, and over here this will be known as what? Our volume integral. Okay? Our volume integral. So these are the features that we need to understand before we consider, before we learn another important topic, which is known as the Gauss law of electrostatics or the Gauss law of electrostatics. Thank you.